So we have here two polarizing filters, and observer is receiving the maximum. So it means the two polarizing filter, the planes are parallel to each other. That's why maximum light is able to pass through. Which row in the table, possible angle for rotation, again we get another maximum, like the polarizing filters are rotated and observing a maxima. If this rotated 90, so means how the plane will be, it will be like this. That is 90 rotation. And this one rotated 180. 180 rotation means like it will come back in the same place. Like if I have like polarizing filter like this, when I rotate 90, so it will become horizontal. Then I again rotate 90, means total 180. So again it will be. So can the light, because this is a light source, so the when the light passes, it will be horizontal polarized, but no light will be able to pass through. So observer will receive no light. So it cannot be A. What about B? Is it clear why it cannot be A? Because the plane of the polarizing filters are perpendicular. If one is rotated 90, another one rotated 180 degrees. Now, what about, like, let's say both are vertical. This rotated 180. If this rotated 180, 180 means like it will be same. Because 90, it will become horizontal, and 180, again, it will become vertical. 270. So 270 means it will become horizontal, because when it is 180 it will be same, but further 90 or 270. So can we observe a maximum light here? No, we cannot observe a maximum. When we rotate, say this was originally vertical, all of them, and we rotated 270. So if we rotate 270, this will become horizontal. And when we rotate this 90, the polarizing filter X90, this will also become horizontal. So we'll observe the maximum light, the unpolarized light, horizontal polarized here, and the polarizing filters are parallel to each other. So we'll observe a maximum light which will pass through the two polarizing filters. So C will be the right answer for this. Question 13, any doubt? 13, 14, 15. 13, 14, 15. No, you can take, it's not like I know that the diagram is vertical. You can also do it with horizontal. You will get the same answer. See, what if you consider they are horizontal? If you consider originally both of them are horizontal and apply the rule, you will get the same result. It will not make difference. Like if you rotate this 90, so means this will become vertical. If you rotate this by 180, it will remain horizontal. So again, no light will be there. So you can start with any, you will get the same result. It does not make difference what you start. But they mention, because the maximum light is able to pass through, so it means the plane of the two polarizing filters are parallel to each other. In question 13, a microphone is attached to an oscilloscope. The microphone detects a sound. The trace displayed on the oscilloscope screen is shown. One horizontal representation of a time is 0.015 second, horizontal division. Which of the following represent the frequency? Frequency is a reciprocal of the time period. So first we work out the time period, like four boxes are there. So the time period will be 0.015 multiplied by 4. That will be the time period. And if you need the frequency, frequency is a reciprocal of the time period. So it will be 1 divided by 0.015 times 4. That will give us the frequency of this wave. So D will be the right answer for this. Question 14, 15, any doubt? Question 14 or 15? Question 16, 17, 18. Question 16. In question 16, two waves of a wavelength 12 centimeter leave the source in phase. The wave travel at different paths and the path difference is 18. So if the path difference is 18, how much is there in terms of wavelength? Because one wavelength is 12. So 18 centimeter means how much in wavelength? So it means 1.5 wavelength. So like say the source is there, this is a source, and the two waves travel and they meet at any point. Okay. They take different parts, and this is a point where the two waves meet. The part difference, like the distance covered by the one wave and the distance covered by the second wave, the part difference is 18 centimeter. So how much is in terms of wavelength? One wavelength is 12 centimeter. So 18 centimeter equivalent to how much in wavelength? So it will be equals to 1.5 wavelength. And whenever a part difference is like you have lambda by 2, you have 3 by 2 lambda, 5 by 2 lambda, 7 by 2 lambda, 9 by 2 lambda, and so on. Whenever a part difference is this, what kind of interference you will have? You will have a destructive interference. Like the two waves cancel out each other. And as the two waves cancel out each other, what should be the phase difference? The phase difference should be 180 degrees between the two waves to completely cancel out each other. So which is representing 180. So pi is representing 180. You can do by this way, or there's also another way. Look, we know one wavelength. If there is one wavelength, what is the phase difference? You can compare in this way the part difference and the phase difference. When there is a one complete wavelength, the phase difference is 2 pi. So if we have 1.5 wavelengths, what will the phase difference? It will be x. You can just cross multiply. So this is, and you have a destructive interference as well, because whenever a part difference between the two waves is equals to lambda by 2 or 3 by 2 lambda or 5 by 2 lambda or 7 by 2 lambda, what will be the phase difference? The phase difference, because it will be a destructive interference. So the phase difference, because whenever a part difference is any of these multiple, like 1 by 2, zero point 0.5 lambda, 1.5 lambda, 2.5 lambda, the phase difference will always be pi radian. What does it mean pi radian? Because this is a condition for a destructive interference. And if it was a constructive interference, what will be the part difference between the two waves? The part difference between the two waves, it might be 0, lambda, 2 lambda, 3 lambda, 4 lambda, or the phase difference, the angle difference between the two waves might be 2 pi, or you can also say 0. This is a condition for a constructive interference. So we identify because it was lambda by 1.5 lambda. So 1.5 lambda or 2.5 or 3.5 all should have a phase difference of pi radian or a destructive interference. Is it clear? Question 17, 18, any doubt? This is also a similar question. Which of the following change would decrease the distance between the central maxima and the first order maximum? Like this x. So we did that, like this x depends on different factors. It depends on the, so we have the formula like d sine theta is equals to n lambda, or sine theta is equals to n lambda by d. And Decreasing a distance from a laser to the diffraction grating, like this distance will have no effect on the like the diffraction at all. So this will not affect at all. Increasing a distance from a diffraction grating to the screen. If we have this diffraction grating or the grating element, and here is the screen is placed, and we are increasing a distance from a grating to the screen, like the screen is moved. So if we change the position, like this will be the central maxima, and the light now will meet at this point. So what will happen? What will happen to the x? The value of the x will change. And the question is, which of the following change would decrease, but this x will increase? So it will affect x, but the value of the x will increase. But we want it to decrease. Using a diffraction grating with more lines per millimeter, that has no effect on the value for the x, like it does not affect at all. Using a light with a smaller wavelength. If you use a light with a smaller wavelength, like as you reduce the lambda, what will happen to theta, the angle? This angle will also decrease. So if the angle decreases, the spacing between the lines will also decrease. Like using a smaller wavelength, it will diffract less, so the theta will decrease. As the theta will decrease, the new value of x will be smaller than the original one. No gap. There's a difference between, look, there's a difference between a gap size and the number of the lines. Like what they're saying we are keeping the gap size same, but we are changing the number of the lines. Like the gap size remains same and changing the number of the line. That is what is done. So using a diffraction grating with more lines per millimeter. And for per millimeter, for this one, using a diffraction grating with more lines per millimeter, if we use the same millimeter and we have more lines, it means we narrow the slit. And if we narrow the slit, like example, if I use more lines per millimeter, then it will increase the diffraction. So as a result, this gap size will decrease. The value of a d will decrease. If a value of a d will decrease, the value of x will increase. So this will affect, because if it was written, how we know the slits become smaller? If you read the part, it's written here. No, no, look, using a diffraction grating with more lines per millimeter means if you have 1 millimeter length, so these are the two 1 millimeter lengths, and you're using more lines. Like say this was original, and if in the same millimeter, if I need more lines, so definitely what will happen? The spacing between the lines I have to reduce. So this d will be smaller. Here d will be larger. And smaller d will cause more diffraction. So when it causes more diffraction, the value of the x will increase. Because it was written per millimeter. If the same question was there and they say that number of the lines, not written per millimeter, then there will be no effect. Because if I increase the number of the lines but I keep the spacing same, if I keep the number of the lines, like increases the number of the lines, but I keep the spacing same, then it will not have any effect on the diffraction pattern. So because in the question they specified here per millimeter, so it means the spacing between the slit is reduced. Is it clear? The difference with the per millimeter makes to the question? And if you read the same question we did previously, why the n was not affecting here? The same question we did was why the, and they asked like how, what are the factors affect? This n is different. The grating has a number of the line, like grating has, n is the total number of the lines on the grating. So in this one, they did not mention number of lines per millimeter. If the number of the lines per millimeter change, the gap will also change. If the gap changes, then the diffraction pattern will also change. That's why we did not select this here. We put cross that this does not affect the spacing. But if it was n was a number of lines per millimeter, in the question they asked, they mentioned that number of the lines per millimeter has changed, then yes, this will also affect the diffraction pattern. Is it clear? So answer for this one is D, because if we use diffraction grating with more lines, it will cause greater diffraction, so the value of X increases. But we want a smaller diffraction, so smaller wavelength will cause a smaller diffraction. Question 19, any doubt? For this one, the Earth and a Jupiter orbits the Sun. The diagram is not to scale. The intensity of a sunlight on the Jupiter is Ij. Which of the following and intensity of a sunlight at Earth? So Sun is a source, so we'll consider Sun has a constant power. Like example, the power of the Sun is P. And the distance between the Sun and the Earth is 1.49 exponent 11 meter, which is also known as 1 astronomical unit. So the intensity on the Earth will be equal, because intensity is always calculated power on a unit area. What area will take? Because we'll take a sphere always. So it will be power divided by 4 pi, and this distance, which is 1.49 exponent 11 square. The intensity on the Jupiter is also the power of the Sun divided by 4 pi, and the distance between the center of the Sun sorry, and the Jupiter is 7.78 exponent 11 whole square. Because the power of the Sun is same, so we can compare the two equations. Like this whole factor will be multiplied there, this will be multiplied, so I can say the intensity of the Earth into 4 pi 1.49 into 10 power 11 square is equals to intensity of the Jupiter into 4 pi 7.78 into 10 power 11 whole square. The 4 pi will cancel with 4 pi, and this will be there in denominator. So the intensity of the light on Earth will be equals to intensity on light on Jupiter times 7.78 into 10 power 11 square divided by 1.49 into 10 power 11 square. So when we divide these numbers, what we get? We get, so A will be the right answer for this. Is it clear? Any other doubt in this? So this was a pop quiz structure, the MCQs pop quiz 9.